Following on from the previous video, I gave you this graph and asked you to work out the area of this purple wave. Okay, from 0 to 20, and the way we did it was we would work out the area of the whole. Well, we would work out the area of the red line. So this bit here, the way we worked out the area of this purple wave would be for us to work out the area of the red line. So the way we did it was this: we worked out this area from 0 to 20. So the way we did it was to evaluate this, which is this area here, and then we would then take away the area of the blue line. So the area of the blue line, we would take away the area of the blue line. So this area of the blue line here, and then what was left was the area of the purple line. So the way we did it was we worked out the area of the red line, take away the area of the blue line, and then what was left was the area of the purple wave from 0 to 20. Now, an alternative way of doing it, well, let's think in terms of Riemann's sum. Riemann's sum is us splitting everything up into rectangles. So bear with me. So we would split everything up into small rectangles here. So let's just look at a random rectangle. Let's just look at this one here. Okay. So when you look at this here, you would get the height of that rectangle. You would get the height of that rectangle, and then times by the width of that rectangle, and then you would add up. You would sum up all the rectangles. Well, rather we were trying to find out this area here. Rather than finding out this whole, let's just zoom in and just look at this rectangle here. Rather than finding out this whole rectangle and then taking away this rectangle here, and then sum up all these rectangles here. Rather than doing that, you could just concentrate on locating this rectangle here and then integrate it all the way across. Okay, so you see what I mean, how? So rather than us doing the whole area, here, and then take away this area here, then take away this area here. So when you think in terms of Riemann's sum, well, it will make sense later on. Bear with me. So this thing here, this bit here, is you working out this whole area here. Okay, and then this bit here is you taking away this area here. And then when you take the integral, you are really summing up all the rectangles from here all the way to 20. Now, rather than doing that, rather than working out the whole area, taking away another whole area, you could do this. You could just concentrate on finding the height first. So what this statement is saying here is this. What that statement here is saying is that just get remember with Riemann's sum here, here you are getting the whole height, and then take away this height here. Well, rather than doing that, rather than integrating the whole area and then taking away this whole area here, you could just concentrate on finding out this area first, or this height first, and then integrate it all along. Okay, so you could do this. You could just get the red line, take away the blue line first. So by you doing this, you're really just looking at the height. You are just really looking at the height. So you get the red line, take away the blue line. That will then give you the height only. And then once you've got the height, then you can integrate all the way across from 0 to 20. Okay, so there is a difference between the two here. This one here is you evaluating the whole area first, and then taking away the other area. This method here is actually a lot easier. It's you working out the height first. So this bit here is really the height. It's just really this height here, and then you integrate it all the way across. Okay, so rather than us doing this, we could do this. Now let's just concentrate on this bit here. Tidy up. So really you've got a positive course here and a negative course here, and then you've got a 5, and then here you've got a -3. So when you tidy this bit up here, it is just 2. So you could just concentrate on integrating this 2 here. The point is that there is a huge difference between this and this. You see, this here is much more efficient because here you're evaluating the whole area and then taking away the other whole area. Here you work out the height first and then you integrate the height, if that makes sense. Okay? I hope it makes sense.